Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, Mathematics is Hot. We'll look at some of the controversies surrounding the hot hands in sports. This is a phenomenon experienced by almost anyone who has played a sport. That wonderful feeling where everything is working perfectly. Hot hands, flow, the zone are all names for this state. How would we go about measuring it? As always, definitions are crucial. Let's try a couple. If someone is hot, then they might have a long string of successes, perhaps 10 in a row. We could look for long streaks and see if they occur more often than we would expect by chance. Backing off of this slightly, 9 out of 10 is pretty hot, so we could look for occurrences of that type. These, like most definitions, are essentially statistical questions. A more general definition of hot hands might be better called streaky. In a player's sequence of successes and failures, are the successes and failures mixed in a statistically typical way? One way of testing for streakiness is called a runs test. Suppose a basketball player has a sequence of makes, K, shown in red, and misses, S, that look like that. Is that streaky or normal? First, we have to account for skill level. In this case, the player has 10 makes and 10 misses. We'll assume that the player is a 50% shooter. We count runs of S's and K's. The runs are of length 1, 1K, 2, 2 S's, and so on. There are 11 runs of different lengths. In a sequence of 20 shots by a 50% shooter, is it unusual to have 11 runs? The distribution of runs is approximately normal with a known mean and variance. In this case, the mean is 11, and the variance is 90 over 19, making the standard deviation about 2.2. You can Google Wald-Wolfowitz runs test for details. So 11 runs is exactly average. No more switches back and forth than typical. But what about that streak of 4 in a row at the end? Did the player get hot at clutch time? 4 in a row only has probability 1/2 to the fourth, 1 over 16, little over 6%. But a run of length 4 somewhere in a sequence of 20 has probability of about 12%. So it's not that unusual. Now, to be clear, we did not prove that the player didn't get in the zone at the end with 4 makes in a row. In fact, by any reasonable definition, the player was hot at the end. What we did show is that overall the streakiness was normal. There are other ways of checking for streakiness. An important one used in many studies is looking at conditional probabilities. If hot hands or cold hands is a common state, then success should follow success and failure should follow failure. In our example, after makes, there were 5 misses and 4 makes. After misses, there were 5 makes and 5 misses. That doesn't look like streakiness. What about in general? Well, to keep the logic simple, suppose we do have a 50% shooter, and that means it's the same as coin flipping, and we assume that those flips are independent. The outcome of one flip does not affect the outcome of the next. For a streaky shooter, however, the outcome of one shot could strongly affect the outcome of the next. Again, a success should follow a success. So we can look at, for example, what percentage the shooter made after a make, or after a miss, or after 2 makes. If these are significantly different, we have evidence of streak shooting. The 1985 study reported in the journal Chance that launched an avalanche of studies was done by psychologists Amos Tversky, Daniel Kahneman, and Thomas Gilovich. Looking at NBA basketball players, they found that there was only a small, statistically insignificant difference in percentage after makes and misses. In fact, the pros' percentage of makes was slightly higher after a miss than after a make. They concluded that the hot hands does not exist and is just a cognitive illusion, kind of psychosomatic. This is a fun topic to debate, which is why so many other studies have been done. And in sport after sport, little or no evidence was found for streak shooting or hitting or putting or anything else. Then a shocking research paper showed that everybody was analyzing the conditional probabilities incorrectly. Miller and Sanjurjo showed in 2018 that in a truly random 50-50 coin flipping situation of finite length, the probability of a head following 2 straight heads is actually less than the probability of a tail following 2 straight heads. What? Everybody was analyzing the stats correctly? Well, yes. After 3 heads in a row, the next one is more likely to be tails? Well, no. The result applies to sequences of flips that have occurred in the past, not to flips in the future. In the sports setting, if there is no hot hands or streakiness, the players are more likely to fail after a string of successes than they are to keep the streak going. Players showing no difference in percentages are actually streakier than randomness, and that shows evidence of hot hands. Most studies have been corrected and show that there is small evidence of hot hands. Why is this true? It's very subtle. It surprised experienced researchers, but here is an experiment that helped me see it. Suppose you flip a fair coin 5 times. There are 32 possible outcomes, sequences of heads and tails. Looking at each sequence, we record the percentage of times that H follows H versus H follows T. For example, in the sequence HH-THT, H follows H once and H follows T once. So we record 50% for HH and 50% for TH. We then average the averages, and this is where the surprise comes, because doing things this way, a 1 to 0 100%, like the HH and HH-TTT, is the same as a 3 to 0 100%, as in HHHHT. Here are the breakdowns. Notice that there's a symmetry. HH gets 100% 4 times, while TH gets 0% 4 times. They're really counting the same thing. Also, TH gets 100% 11 times, while HH gets 0% 11 times. That gives a big advantage to TH when we're averaging the averages. And in fact, the averages of the averages in this case round to 41% for HH and 59% for TH. If you look at somebody's string of 5 hits and misses, you should expect to find that a success follows a failure more often than it follows a success. Of course, you would never base anything on just 5 shots, but this shows why the Miller-Sanjurjo result is true. The gap between percentages shrinks as the number of shots increases, but for most of the studies done, the effect is still sizable. The analytics community now supports the idea of streakiness or hot hands in sports. However, that does leave open the question of its cause. Put one way, do players somehow get hot in the zone, and that causes great outcomes? Or do players experience successes, and that causes the feeling of being in the zone? It's an interesting question, and not one that mathematics is likely to answer. We'll explore some of the ways that math can shed light on the psychology of sports in the episode titled Psychological. Meanwhile, here's hoping that you enter that mystical zone next time you compete.